Agent Sprawl, the 2026 engineering risk your auditor hasn't named yet. Right now, across your engineering organization, some number of AI coding agents are running in parallel. A few sit inside Claude code sessions in work trees you never see. Others work against branches nobody has pushed. And some are committing to repositories owned by teams whose AI tool budget you never approved. You do not know how many. Neither does your VP of engineering. The developer who kicked off a second Copilot agent 13 minutes ago in a separate worktree does not know either. They just opened another terminal. Put that gap in front of a SOC 2 Type 2 review in 2026 or a pre-acquisition technical diligence, and it reads as a finding. The category needs a name. Here is mine, Agent Sprawl. The threat? Named. Agent Sprawl is the uncontrolled proliferation of parallel AI coding sessions across an engineering organization without unified audit trail, isolation pattern, or per-team measurement. Your SIEM will not flag it. It is not a security incident. It is not a feature flag your platform team forgot to toggle. It is a structural condition. The thing emerged through 2025 and hardened into operational baseline by mid-2026 in most engineering organizations of any real size. What is missing is the instrumentation. That gap is what this article is about. Here is what one Agent Sprawl incident actually looks like. Agent A is iterating on a refactor on feature payments v2. Agent B starts 50 minutes later, launched by a different developer in a separate worktree on bug fix payments rounding, and opens the same file to ship an unrelated fix. Both branches were cut from main. Gits neither sees the other. When the two branches merge back to main, Git's three-way merge resolves the textual diff cleanly. Semantically, though, Agent A's refactor removed the helper function that Agent B's bug fix path still calls. The unit test that would have caught the mismatch? The bug ships. That is sprawl at the IC level. Now multiply it by the number of branches live in a 40-engineer team. The audit trail becomes a wish, not an artifact. The blast radius, 3 numbers from the last 6 months, set the scale. 72% of developers who have tried AI coding tools now use them every day, and AI now accounts for 42% of all committed code. Sonar State of Code Developer Survey, 2026. 96% of developers do not fully trust that AI-generated code is functionally correct, yet only 48% always check their AI-assisted code before committing it. Sonar State of Code Developer Survey, 2026. 30% of engineers spend a third of their week on repetitive infrastructure tasks and audits. Duplo Cloud AI Plus DevOps Report 2026, translated for engineering leadership. Adoption is already universal, the productivity reality is uneven, and the operational tax on your team is high enough on its own that stacking uncontrolled AI sessions on top makes things worse, not better. The blast radius is on the record too. Earlier this year, a misconfigured set alarm loop inside Cloudflare durable objects ran up a $34,995 cloud bill in 8 days, April 3rd to 11, before the developer noticed. Cloudflare's billing system at the time had no real-time spending caps and no usage notifications for durable object operations. Same shape of incident, routine 2026 possibility, vastly larger surface area. I have watched this surface grow firsthand across the 50-plus public repositories I maintain, and inside the production environment I run for 150-plus engineers. The count of distinct AI agent surfaces touching the code base roughly doubled between October 2025 and March 2026. The visibility layer did not keep up. That asymmetry is the operational shape of Agent Sprawl, well before any auditor gets around to naming it. For the per-agent walkthrough I ran on a live environment last quarter, I tested an AI agent on my live systems. Here is the blast radius assessment. Why this is a board-level question in 2026? 4 reasons ordered the way they will hit the board deck. Audit scope is evolving. SOC2 Type 2 practitioners are asking more and more about AI-assisted code provenance. AI CPA guidance is still maturing as of mid-2026, but auditors already fold AI tool inventory, access controls, and code review of AI output procedures into their walkthrough questions. If you cannot show that AI-assisted code gets reviewed under the same controls as human-authored code, that is a finding. EU AI Act enforcement is live. Engineering organizations that produce software for EU markets fall within scope for obligations around AI system documentation and risk management. Exactly how that lands on internal AI coding tools versus AI features you ship inside products is still being clarified through 2026. Operating with no internal record of AI tool usage is a bad place to stand when the clarity arrives. Acquirer due diligence has caught up. Tech diligence checklists in 2026 routinely ask about AI tool usage, AI-generated code volume, and AI governance documentation. We do not track that was a fine answer in 2025. In 2026, it is a valuation discount. Cyber and E&O insurance underwriting has caught up. Several carriers now put AI governance disclosure on their renewal questionnaires. In most cases, the lack of it is not yet a coverage denial. It does raise premiums and narrow coverage scope, the senior engineer signal. This is the data point most worth sitting with. From the same Sonar 2026 survey, junior developers report the highest productivity gains from AI, and senior developers report meaningfully smaller ones. The survey also notes that experienced developers value AI's impact on technical debt and documentation differently than junior peers do. Recall the split from earlier. 96% of developers do not fully trust AI-generated code is functionally correct, but only 48% always check it before committing. The seniors are the ones flagging that gap loudest. That is not a generational gripe, it is a signal. The cohort with the deepest experience reading systems that look correct but are not is the least convinced this trajectory is net positive. Part 2 of this series gets into why that signal matters more for engineering risk and talent retention than most boards have heard. 20 years in, I will just say it, the people with 20+ years on the floor have watched several transformative tooling waves show up without the supervisory layer keeping pace, and they know the shape on sight. The skepticism in that cohort is a leading indicator, not noise to filter out. The market response, the first practical instrumentation for this category, is starting to ship. Xero introduced agent mode with a dedicated view it calls Agent Sessions View in the left panel. Per the published release notes, it is a unified dashboard for worktrees and active agent sessions. Every worktree shows up as a card. The card displays the branch, uncommitted changes, ahead, behind state, and associated pull requests. For Claude Code users specifically, the associated agent's status surfaces right on the card, working, waiting for input, errored. The new agent session action creates a worktree, runs configured setup commands, and launches the coding agent in one step. Per worktree setup commands, dependency installs, build steps, environment file copies can be configured in preferences, so new agent environments come up ready on their own. So this is the worktree per agent isolation pattern made operational, with an audit trail-friendly visualization layer on top. Worktree per agent is also the right primitive, and that distinction matters. The intuitive default is to aim two agents at the same feature branch and let them collaborate. In practice, that fails the instant either one touches a file, the other is editing. The conflict shows up at commit time, not edit time, and by the time anyone notices, the work both agents have done is already entangled. Worktree per agent inverts the order. Each agent operates on its own file system copy of the branch, edits there, and merges happen explicitly through a pull request a human reviews. The cost is disk. The gain is that agent collisions stop being silent. It is also what makes the per agent measurement, item 4 below, possible at all. You cannot DORA segment what you cannot tell apart. Running it day to day, the change is operational, not cosmetic. I used to carry a mental map. Which terminal is which worktree, which agent is mid-task, what branch each one sits on. That map moved into a visible state I can scan in 2 seconds. Cards in a grid, branch and ahead, behind, counts on each. Agent status, working, waiting, errored, right where the eye looks for it. Recovering that working memory is the part I had underestimated. My old terminal plus Tmux flow kept the cost invisible. Once it is visible, the parallel agent workflow stops being a tax I pay to ship faster. It becomes a tracked surface I can reason about, hand off, and audit, control protocol, what instrumentation for agent sprawl looks like at minimum. 1. Unified audit trail for all parallel AI agent sessions. One pane of glass where every active worktree with agent is visible to the developer, the team lead, and, with appropriate aggregation, the engineering leadership reviewing organization-level AI usage. 2. Isolated environments per agent. The worktree per agent pattern is the right primitive. Shared branches with multiple AI agents writing to them is the wrong shape. The pattern keeps each agent's surface area observable and rollbackable. 3. Risk scoring layer on AI-authored pull requests. Size, complexity, and change scope are signals that should trigger reviewer assignment and elevated scrutiny before merge. This is automatable today. 4. DORA measurement of AI impact per team, deployment frequency, lead time for change, change failure rate, and mean time to recovery, with before and after AI adoption baselines, segmented by team. Without segmentation, the aggregate hides everything that matters. For the measurement framework I have used to do this segmentation cleanly, see AI didn't fix productivity. Measurement did. 5. Voice of developer survey alongside the quantitative metrics. Numbers tell you what happened. Survey signal from the engineers actually using the tools tells you why. You need both. Either one alone misleads. The first commercial implementation of this measurement layer I have reviewed is Git Kraken Insights, launched October 2025 in partnership with engineering analytics specialist GitClear. It runs on a stated design principle that matters here: measure teams and workflows, not individuals. That principle is correct. The moment your AI impact measurement turns into individual surveillance, you lose data quality and you lose the senior IC trust you most need to keep. 3 questions for your next engineering leadership meeting. Take these as written. If the answers come back fast, your engineering organization is ahead of most. If they come back as, "We do not track that," you have your starting point. 1. As of right now, how many AI coding agents are active across our engineering organization? 2. Where is the audit trail for AI-assisted code changes from the last 90 days? And who has access to it? 3. What is our baseline DORA performance from the 6 months before our most significant AI tool adoption? And what does the comparison look like now? Most engineering organizations will not have agent sprawl instrumented by the end of 2026. The ones that do will show up cleanly in next year's M&A and audit cycle. The ones that do not will spend the cycle after that explaining the gap. The work to close it is a quarter, not a year, but it has to start being named. GitKraken Ambassador Note. As a GitKraken ambassador, I write about the tools that change how engineering teams operate at scale, not the ones with the loudest launch posts. Agent Sessions View is the first piece of dedicated instrumentation for agent sprawl I have reviewed. That is why it lands here. The category exists either way. The instrumentation is now starting to exist alongside it,